There are three things that affect the density of a material in general, but specifically a fluid, and those would be pressure, temperature, and humidity. And we need to be careful about these because if we're going to fly an aircraft, the pressure can change if different weather systems move in, as can the temperature. The humidity can also certainly change as well. Pressure and temperature have a much larger impact on the overall air density. Humidity, not so much. So we're going to focus primarily on pressure and temperature. So to understand the relationship between density and pressure, we want to imagine like a vessel here filled with these purple dots, which is essentially some kind of air that's spread out since it's a gas. And that's a piston on top. So that's kind of like a lid that can move up and down. So right now the mass is able to kind of spread out. That's uncompressed. So we say that that has a low density. If I were to push down on that piston, I have the same number of molecules, but now they're forced to take up a lower volume of space, so we say it's compressed. So all that mass fits into a smaller volume. So we have a lower pressure in the case on the left and a higher pressure in the case on the right. And we therefore say that there is a lower density on the left and a higher density on the right, because we'll find more molecules in a smaller amount of space in the diagram on the right. So density and pressure have a direct relationship. As you increase the pressure of the air or the fluid, the density of that air or fluid will also increase as well. And what does this mean for aircraft? Well, essentially, the higher you go in altitude, there's a decrease in pressure. So the pressure, atmospheric pressure, comes from all the air that's above you that's pushing down on top of you. So much like when you swim to the bottom of a pool, your ears, you might feel pressure in your ears because all that water above you, since you're going down, you have more and more air above you, is pushing down from above. So much like the water in a pool, the closer you are to the Earth's surface, the deeper you are in that atmosphere. So as you rise up, just like your ears won't feel as much pressure in that pool, as you rise up in the atmospheric pressure decreases as well, because there's less and less and less air above you pushing down on you, compressing everything beneath it. So at the end of the day, density decreases with altitude, density decreases with pressure decreases. So whatever pressure does, density does, pressure decreases as a result of altitude, and therefore density decreases as well. The other variable that we're going to take a look at is density and temperature. So you'll have to think back to chemistry, but temperature is essentially a measure of the kinetic energy, or the energy associated with the vibration or the movement of particles. So if you have this balloon and it's filled with cold air, we have molecules that are certainly moving around. They're just not moving around super fast, and that's what gives the balloon its shape. The collisions of those molecules with the balloon itself is what keeps that balloon kind of inflated and pushed outward. If I were to heat up those molecules, they're going to start to move faster. They're going to have more violent collisions with the balloon, and that's going to push the balloon outward. So if you were to heat a balloon up, or if you ever have had a soccer ball or some kind of athletic ball, like a football or anything, and you leave it outside on a cold day, a lot of times you'll pick it up and it's flat because the air is not vibrating or not moving around as much inside, and it shrinks. Well, alternatively, if you pump like a soccer ball up on a cold day and then you leave it outside as it becomes summer, there's a chance that that ball is actually going to rupture, because as that gas expands, as the temperature increases, you could potentially, rupture the bladder inside of the ball. So what we need to realize here is that temperature and density are inversely related. As temperature increases, the volume tends to expand because those molecules are moving faster and they're pushing out further on whatever their container is, and therefore the density decreases, because as you take this mass of air and it expands, the same mass of air takes up less of volume. And what does this mean for aircraft? Well, depending on whether it's a cold or a hot day, a cold day you will have more dense air. On a hot day, the air will be less dense. With more dense air, those propellers have more air to push off of, and that engine will perform better. Whereas when the air is less dense, just like if you were to go higher in altitude, as the temperature increases, there's less air to push off of because of the lower density, meaning you'll have less thrust on a hot day than you will in the same conditions on a cold day. It's actually more efficient physically to fly on a cold day because there's more air to push off of. The last one would be density and humidity. The humidity, which is water vapor in the air, actually it's seems counterintuitive, but there's less mass than just dry air. When humidity mixes in with the air, there's actually less mass than dry air. So because you have less mass in the same volume of space, they are inversely related. As humidity goes up, density goes down, but the effect is really minor, so we can pretty much ignore that. We're not going to look at that in our calculations, but it's important to note that as humidity increases, air density decreases, but not really to the point where it would ever drastically affect aircraft performance. Primarily it's pressure and temperature, and we'll take a look in the next video at how we calculate that and how we can quantify that impact.